right. So my topic for today is to discuss maybe something a little bit different from this conference. It is to talk about how to use AI ML to provide better product and service quality. And specifically, I mentioned here the age of everything as a service, which is the general trend nowadays. Even the company I work for today, Dell, that traditionally sells their product directly to the customer, now also offering their product actually as a service. So even though they ship product on site to the customer's data center or on-prem, the customer still can basically purchase the infrastructure as a service where Dell manages it, maintain it, and run it, and all they do is basically use it as a service. So that's the idea. So here are some of the key takeaways. I'm going to talk through all of them, but essentially, when I started working at Dell, I was tasked to figure out how to apply AI ML on solving some of the problems in tech support. Basically, how do we speed up the time to resolve to figure out what is the issue, what's the root cause, and what do we do to remediate the issue? So I'm going to talk a little bit about how I worked in my project at Dell in the last 2.5 years. And the agenda essentially, I'm not a data scientist, so I'm not here to try to educate you on the nuances that's involved in data science. But mainly, I would say I'm a user of the technology, and I've come to learn a lot about data science in working with data scientists. So I just want to make, given that I don't know how much you guys know about data science and know about AI machine learning, I'm just going to walk through some very basic definition so that, so there's a level setting here that you understand the terms, at least I'm using to talk about these projects. So this is a very high level definition of AI ML and deep learning. Again, it's, you can find these definition online. Basically, AI is the general category, and then it's inclusive of machine learning, and then also deep learning. And all these techniques are utilized, right, in basically in trying to solve the problem of doing detection of failures and try to figure out what the resolution would be. All of the technique that's involved would be utilized. And here I just want to, I'm going to talk about probably this a little bit, which is, try to talk about the two major types of machine learning, supervised and unsupervised. And essentially, this is just to tell you that the supervised means we have labeled data. The labels tell you what the data means. It goes to the model, and you could produce an output prediction, an ML model that would help you differentiate between the different class of objects, right? The class of that you want to identify. And the unsupervised just means we don't know what's there. We're just going to let machine model segregate the different types of objects in the data, and then we'll sort them out into, in this example, apples and watermelons. Here, I'm just going to go over very quickly some of the terminologies that you heard before, like AI ops, right? So just to kind of relate to, you guys should all know quite a bit about DevOps, right? Particularly how, K is a part of that process. And today, because you're developing machine learning models, there's the idea of ML ops, which is incorporating model building, and using the data to build this model as part of product development process. And you'll probably have heard about this, today as part of incorporating AI ML into your applications. And the key thing that I want to introduce here is, of course, this is something I grabbed from Gartner's website. It's their definition of AI ops. And essentially, you can go to their website, you'll find this chart. It's just, the idea is that I want to be able to ingest historical data that's collected about the infrastructure, the system, the software that's been running, and I want to basically make some sense from that to build models. And then when I ingest real-time data, meaning things that are ongoing, right? And then I can then run inferences, which means executing the model to produce a prediction to tell me what's happening, right? What is there an error or not? Or if there is an error, what type of error is it? So that's essentially the general concept of AI ops, is to apply AI ML on IT operations. So here I'm going to spend a little time and talk about the use cases that I've been focused on in the projects I've been doing at Dell Technologies. So the current manual support process that everyone should be familiar with is the customer has some product, infrastructure product, IT product. The idea is that we either have ways of collecting the information about, the logs, telemetry of what's going on these systems, either automatically over the internet, right? It's being collected. And that's typically what you'll see in modern infrastructure products, is that they'll do this automatically. In the old days, of course, you download them over the internet, FTP and so forth. But the idea is that you need to collect them to do troubleshooting, right? A customer calls with a problem, you open a ticket, the agent will now perform, troubleshooting and remediation. So what happens now with AI/ML is that you take the ingested data, the telemetry and log data, and you look for patterns, right? You're trying to figure out what can it tell you about some of the problems that the system are facing, right? And the use case is that if a new problem happens, I already have analyzed and looked for those patterns, and I already know what it is, then I don't need to do it again, right? So I can reduce my mean time to resolve by doing issue identification, right? And the general concept there is I'm building a better hospital. The patient, your customer is the patient, he or she gets sick, they come into the hospital, you could figure out what's causing the problem, what's causing the ailment. You can then prescribe, right, a remedy and get your patient out of the hospital. And now we take, like I said before, we are looking for patterns in the data. We're building the models, and you're identifying the issue and you're recommending the resolution. It goes to the tech agent, right? So this is how you're reducing your mean time to resolve. The other very critical component of that is agent providing the feedback to the model to say, yeah, that prediction is correct or that prediction is not correct. That will further refine the model and improve its accuracy over time. And this is a very critical part of continuing to improve the model's capability. So the use case number 2 is that we are able to recognize those patterns. Can we predict them before the error actually happens, the failure? So here, the idea is that we want to build a defense. It protects the customer from ever getting into a failure state and to call us and, requiring us to take retroactively or to the fact, taking action to remediate. And the last use case is that, if we can provide this capability directly to the customer themselves, and they can use that knowledge and capability, insight to have a better experience, meaning they don't even need to call us, right? To be the best. That's the end goal. So here I'm going to talk more about how are we going to use AI ML to improve service quality? What's the, so what is it going to do? Why would it help to improve the service quality? Well, here the idea is that traditionally, as I discussed before, you have a human being, a tech agent, right? New trouble tickets are open. They have to go through troubleshooting. They have to manually examine what's in the log, and then they figure out what the root cause is. They resolve the ticket. So now we apply AI and machine learning, which means we take the output from before, the resolved tickets, right, and the collection of telemetry and log data, and it's digitizing that knowledge through machine learning, and the model encapsulate that insight, that knowledge, right? And it learns from that. And therefore, you can apply that digitized knowledge much faster, much more easier, and it will essentially scale, right? The idea is that imagine if you're managing as an IT vendor, you're providing service, everything as a service, and if you still require human beings to manage and maintain and keep up your service quality and meet your SLA, if you don't have AI machine learning means, you're going to have to hire a lot more people, probably a lot more people than you can, it might make the service unprofitable if you have to keep hiring more and more people, right? So this idea of using AI/ML is actually very critical in ensuring that you meet your SLA, provide a high level of service quality, right? And be able to automate and scale to make that service profitable. So that's why it's very critically important. So I talked about one of the use case, mean time to resolve reduction, right? This again is just showing a picture of what that looks like. So here, what I would say is one of the patent that I have filed is it's basically a method assistant for building supervised machine learning models to do issue identification and then to predict resolution. I'll talk a little more about that at another slide. And here's use case number 2. Again, the idea is that as you have these telemetry log data coming in real time, you're going to look for those patterns and you're going to predict them. So here I've talked about using models, but here there's also people use rules, right? So you could create manually rules in terms of what data to look at in log that would help you identify an issue. Now, so why do I still have there? Why not just completely rely on AI machine learning? Because there may be new problems. New problems come up and you need to react. So model building requires a significant amount of historical data to train. So rules as a way to mitigate issues that come up more recently, until you build up enough historical data to build models, you probably will always still require using some form of rules to identify issues automatically, right? And I have a dotted line here to self-healing, which is a future capability. The reason we don't go directly into self-healing or self-remediation, instead we do a dashboard notification, right? Or whatever form of notification. The reason is because there's lots of things going on, particularly when the service is live. You think about everything as a service. So what is the current workload? What is, how many users are on the system that's using the platform that you're providing? Although, all factors will decide what the remediation should be and when you would do it, right? So clearly, at some point, the self-healing can happen, but the system needs to do more than just predict failures. It needs to actually have an understanding of the environment which the structure sits in. It needs to understand the workload, the performance, and other stats around what's going on. So that will eventually happen, and that's called self-driving infrastructure. And I have another patent here, which is to basically predict basically impending failures. Right? Look at log data patterns, make a prediction about whether a particular type of failure will happen. But in addition to that, give you a time failure. Is it going to happen in an hour, in a day? So that is also very important, right? Because the more lead time you have, the better you're able to address and mitigate some of those problems. So this is a slide that just kind of talk about my first AI/ML project at Dell. So everything here you kind of saw before, right? So we're taking in information from the customer system, and here I'm showing you what telemetry is the configuration, which are what's the model, what's of the infrastructure, what's the OS version, or what's the software version of the application running on the infrastructure. how many disks it has, what kind of CPU it has, that kind of, the configuration of the system. And then performance is, how fast is the CPU being utilized, how much memory is being utilized, how much capacity is remaining on the hard drives, so forth. Things that tells you what is happening in terms of the workload on that platform. And signatures are basically identifiers of issues, right? These were basically, I talked about those rules before. So those signatures are basically rule-driven signatures that extract certain data that tells you there's a certain problem, right? So again, we coupled that with the case data, which the customer calls in to open a trouble ticket case. And we utilize that to train our models. And then we do the predict, right? So here are some examples of the type of prediction we do, which is we want to classify the case. When a new case come in, we want to give the agent an idea, what is this case about? And in this case, in our trouble ticket classification, there's a thing called the problem and resolution code. So that gives the agent an idea what kind of problem this is. And then we also want to predict what the resolution is. In this case, it's a knowledge-based article. So this is looking at history, how similar cases were resolved in the past, what were the knowledge-based articles that were written about the resolution, and we can go and predict it so that the agent can go look at the knowledge article, and that will help them to do the remediation. Now, if all else fails, what we can also do is look for a trouble ticket that looks very similar to the one that the agent is working on. So that's basically the three different predictions we try to do in this project. So I'm not gonna, I won't be able to share, of course, the detailed data related to those projects because those are proprietary. But obviously, what I will say is that, you build the models, you're gonna get some level of accuracy, and then you keep training them with more, as you get more data. And also, like I said before, the feedback from the tech aids to the accuracy will, drive up the accuracy, drive up the predictive accuracy. So that's how you're gonna go from, starting in the beginning with maybe not so great, right? And you keep improving over time. So that's just part of the process that you go through. So here are some of the things I've listed here that are, I would say, core lessons, right? And I think it may dispel some myths about the use of AI ML, which is, if you have the data, data science is going to help you find, the insights. The answer is, if the data does not contain the insight, then it's not going to find them, right? Because garbage in, garbage out. So the data is very important. So in order to build effective and accurate models, the data has to be of high quality. So a lot of work is done before you build the models. A lot of the work is done on data processing, right? Data engineering, making sure the data that you eventually use as inputs into the models are correct, are relevant, and useful, right? That's one of the things I found is that 80% of the time is spent at that upfront effort, and the model building is not, actually doesn't take that much time. And that means that when you are building application with the idea that you're going to use the output of the application for data science, well, you need to design that with the idea that this data be used later to build these predictive models, so that you don't just end up with a bunch of data and you just ask the data scientists to go find something in there. They they may not be able to find anything. So you have to do a lot of rework to figure out what that is. So it's very important to think about that from the very beginning. And also, one of the things I learned about is data retention, right? The more data you have, like I said, historical data, the more data you have, the better your model will get. And part of it is that it takes a lot of storage space, petabytes of data. It costs money. So yeah, it's a balancing act, how much how much data you keep and how long do you keep it to give you the necessary predictive accuracy in your model. And I hear one of the things I can tell you is that supervised models are more effective than unsupervised models because it's going to tell you exactly what the issue is, whereas unsupervised models will tell you, yeah, something looks wrong, but we don't know what it is, right? But it's more difficult to do supervised models because it requires labeled data. And if you have, millions or tens of millions or hundreds of millions of log data, it's a monumental task to actually label them. So that goes back to one of my patents. It's how to effectively build supervised models, right? Without having somebody manually labeling the data. So that's one of the critical problems to solve in this space. And one other thing I want to talk about is that the makeup of a successful project is that you need people with domain knowledge, right? So in the team that I worked on, we involve tech support and people from product, right, along data scientists. So it's the combination of all these people from different domains that contribute to making the project successful. You can't do it just with the data scientists alone. That's the key takeaway. And this now has become kind of obvious from the things I've mentioned, right? Needing the domain expertise, having quality data, well-defined use cases, and so forth, to make sure you have a successful project. So thoughts about applying AI/ML to QA. I can tell you, aside from these ideas, I can tell you for a fact that I have now found QA teams within Dell that are using AI/ML during the product development process to do, as part of their test cases, right? They build these models and use them to identify issues. So this actually is happening. It's not just my idea, but there are actually groups within Dell that are doing it. So I see that being standardized into the product development process at some point across all the products at Dell. Versus right now, today is still kind of an ad hoc one-off. People are just trying to figure out how to use it effectively and apply it to the work they do today. So I think that's the end of my talk.
Thank you, Dale. We have nearly 10-15 minutes for questions. That was a very interesting topic and presentation. I'm sure we can use it across all organizations. So if you have any questions for Dale, please go ahead and post in the chat. Also, please feel free to fill out the survey for Dale so that we can bring him back to next year PNSQC, as well as please fill out the PNSQC surveys as well. Please go ahead and post your questions in the chat. So we have a question, Dale.
Yeah, okay. So the question is, I mentioned that data is the most important part of ML testing. I couldn't agree more. What kind of strategy do you recommend for reducing bias in your initial data set in order to continually produce reliable and accurate results? So reducing the bias is, I think, a part of the work that our data science team do. It's not something that I personally got involved in. So I would just say that, yeah, there are obviously ways to do so, but I don't have the intimate knowledge of what specific techniques are used. If we want to start looking at machine learning for gaining insights from Datadog logs, what resource would you recommend? Okay, so I'm not familiar with Datadog. I assume that's a product that is for QA. Is that correct? So I'm not sure answer that question. I apologize. Okay, so it is a data logging tool, right? So without knowing the specifics of the type of data that Datadog collects, I don't know how to answer. But in general, typically what I to see in log data is that what you should look for is I would compare it to trying to learning a new language, right? So you need to understand what is the structure of the log data that you get. There's what are the definition, what's the grammar, what kind of informations that are there, specific standards in terms of what the message ID means. Like, so for example, in the log data that I do look at, we have different severities. So there are failure, there are alerts, right? Failure messages, there are informational messages, there are warnings. So those, those are the type of information you need to understand about the log so that you could interpret it correctly when you want to build models to produce some insight, right? So so the level of understanding of the log is why it's critical. So I mentioned domain knowledge is needed because for every product that you look at the log data, they will be different, right? There's no standard between how the log message will look from one system to another. And when I say system, I mean product, right? So the idea is that, for whatever product you're looking at, typically they have their own logging language, right? So understanding that would be very critical.
Thanks, Dave.
Yep.
Can you recommend any specific tools for AI or ML testing?
So let me see if I understand this question. So when you say AI ML testing, are you saying you're testing the models, or are you saying using AI ML as a way to test another product? I'm just not sure what I mean by that. So so what I would say is right now there are tools out there, packaged tools that help you build models and help you test the models and help you monitor models. I don't have a recognition because in this space there are many different, and I don't know how good they are because there are so many different tools and a lot of them are fairly new. So it's hard for me to even begin to tell you, but I can only say that yes, there are these tools. Whether they will work for your specific case really depends on what you're doing. So I think part of the problem with AIML right now is that it's kind of a nascent field. It's very new. There's not a lot of standardization yet. I don't want to give any recommendations because I really don't know how good they are. Okay, so all right, I think I did interpret the question correctly.
Yeah, I think this is for the model testing, just referring to. So I have a question, meanwhile. So you mentioned about 2 patents, right? And yes. I assume the patent was around the predictability issues.
Yeah, so so the first patent is around how to, so the title of the first patent is System and Methods for Automatically Generating Label Data for Supervised Machine Learning. So automatically, so right now, like I said before, one of the big challenges is labeling the data for a supervised machine learning model. And when you have so much data, right? There's a huge amount of data, and it's impossible to manually label all of them. It's just not possible. So the first patent is it's not a patent about any particular way of modeling. It's about how do we create the data that's necessary to feed it into a model in order to build a supervised machine learning model to identify or predict what the issue is. That's the first one. The second one is looking at just logs, right? Looking at just logs and looking for patterns of log data that would predict the occurrence of a failure, right? So we know in the log that there are failures, right? It records them. So you look, so this one has to do with applying machine learning to look for the pattern preceding the failure, right? So that I can predict if it's going to happen again. But then I try to do one better, right? Which is I'm going to also tell you when it's going to happen.